Oh wow, yeah. Oops.
Right, so my name is Jindřich Bär, and I'll be talking about web scraping. I work with the company Epify, which does web scraping. We're located here in Prague. And yeah, I'm not really great with public speaking, so if you have any questions anywhere, something is unclear, please just ask me. Good. So I'll start with what Epify does. I promise this is the only slide in the whole presentation about the company, so bear with me. It's important for the rest of the presentation. We are a cloud platform that does web scraping and browser automation, web automation. What you can basically do with Epify is you can take your Docker image and upload it to our platform and add some JSON files describing what inputs the Docker file takes and what outputs it produces. And the whole thing is called an actor. And things you can do with those, you can either run your own actors, so just take your Docker image, send it to our platform, run it there, or you can publish your actors and possibly monetize them. So you let other people run your actors, and so they pay you for each result it produces or each second it runs. You can set that up. So that's one thing, we have this platform, but we also maintain open source projects. The largest projects we maintain are Crawly for JavaScript and Crawly for Python. This is a web crawler development framework. So we also have our own devs maintaining our own actors, and therefore we needed a way of writing those actors easily, so we don't have to repeat the same thing, crawling the page again and again. So we created a framework. It's on GitHub. You can check that out. And so Crawly for JavaScript and Crawly for Python are two projects, maybe the largest ones we maintain. But then we also have a lot of tools that help us with scraping, like small called miscellaneous web scraping tools. Some of them I'll mention further down in the presentation. And so now, web scraping. We're out of Epify. I won't mention Epify ever again. So, web scraping. If you ever tried scraping the web with curl, right? It should be as easy as this. Alza is basically check Amazon, an online store with electronics. So, scraping the homepage should be as easy as this, right? So when you run this command, you get something like this, which looks fine, right? That's the content you should get. It's some HTML. It's probably also HTTP 200 response, so it should be fine. It says just a moment. So what does that mean? Is there some JavaScript it's trying to load that the content there is dynamic? Well, you probably know that just a moment means that you got trapped by Cloudflare. And so these come in many different flavors. You get these captchas, you get these puzzles, little riddles. I don't even know how to solve some of these. They're more of an IQ test than a captcha. But so yeah, this way you see that the server noticed that you aren't trying to access the page with a regular browser, but you're trying to automate it somehow. Well, my question is why do they do that, right? It's a very simple question. So there are multiple reasons. One of them is that some of the data might be protected by GDPR here in the European Union. Some of it might be copyrighted. For many pages, like social media, the content is their business, right? Without user-generated content on TikTok or on Instagram, if you just take the content out of the platform, nobody wants to use that platform if there is nothing interesting to see there. Also, if you come to the web page with an automated script, the bot won't click ads, won't see the ads, won't try to buy subscriptions, so they're losing money. And maybe the largest problem, especially nowadays, is that automated scraping increases the infrastructure load. The servers have to process more requests, generate more responses, and this is a larger issue nowadays with AI. Everything, the use cases where people just scrape the whole website for their LLM chatbots and stuff. Well, now that we know this, we can decide to just ignore that. and think about how the websites resist scraping, because that's a bit more interesting, because we're trying to overcome that, right? So when you see that Cloudflare CAPTCHA page, sometimes it just loads for a bit before it shows you the actual CAPTCHA you have to click. So what it does at that point is it runs some JavaScript checks in the background. Those methods in general are called browser fingerprinting. What it can do is it accesses some internal properties of the JavaScript environment, like navigator.userAgent or screen size, tries to figure out whether the user agent that JavaScript tells it has is the same as the HTTP request had, whether that matches. There are some more complicated ways of fingerprinting, like Canvas. It creates a Canvas element, writes some data into it, and it reads it pixel by pixel, and different operating systems and different browsers, have some slight differences in what colors or what values will be there in the canvas. So those scripts can figure that all out and can tell whether you're lying about what browser you're using or what operating system you're using. The fix for this is just to use the actual browser binaries, the ones that your regular customers use, and that should be just fine. You probably cannot, fake or spoof the fact that you're on, Linux when you're trying to tell it you're on Windows, just because all of these canvas fingerprinting methods. But as long as you have plenty of those browser binaries, you might be just fine. Another method is HTTP fingerprinting. This is a bit more relevant for projects like curl. So if you ever tried scraping with curl, the first advice everybody gives you is just send a user agent header that's from a regular browser. And well, that's not completely true, because the headers the header set of regular browsers contains other headers that sort of reference to the user agent. So these user agent hints, I think they're called. It says whether you are mobile or not, or what kind of operating system you're on, and these all have to match. So if you only send the user agent, it might not be enough, because the fingerprint might not be consistent. But still, if you just gather all the headers from your regular browser and you just put it as the -h options to curl, it's still quite easy to spoof these headers, to overwrite. But for some servers, this is already good enough. Sometimes you can just pass the bot checks by just changing the HTTP headers. Now the next step is that sometimes this is not the headers are not enough, because the servers try to look a bit more into the HTTP data you're sending into your request. Here, they're often looking into things that are not set in stone in the standards of HTTP, like HTTP headers order. That's not, well, there are some things some headers should be before others, but it's not like there is a static set of headers and they should go in this order. And there are other things, and these mostly depend on how your HTTP client is implemented, right? It's not, because it's not set in the standard, you just decide to put the headers there in some order, just how your code goes, and that's how they'll appear to the server. And well, in different browsers, let's say in Firefox or in Chrome, this is implemented in a different way, so the headers will appear in a different order. It doesn't matter for the actual HTTP connection, but the server can tell that you are, let's say, Chrome, but you're overwriting the user agent with Mozilla Firefox user agent. Well, these are a bit harder to spoof than the previous group, because that the HTTP headers order is not standardized. The libraries can just decide to even if you pass custom headers, you can just decide to order it as they like, because it shouldn't matter, right? So especially in languages like Python or JavaScript, with the clients, you often pass headers as like a dictionary, which is by definition not ordered, because again it shouldn't matter, and the library just orders it on its own, and can result in an, again, inconsistent fingerprint. And on this slide, it's the last, but it's definitely not the last way of fingerprinting HTTP clients is TLS fingerprinting. Maybe a little show of hands. Have you ever heard of TLS fingerprinting?
Yeah.
Oh, that's great. Not telling you anything new. Okay, I'll go very fast through this. You probably heard of the JA4, JA3 fingerprints. They just take the client hello message, they take some parts of it, make it into a hashed fingerprint and compare that to their database. And what's important for us, as most of our actors are written in JavaScript or Python because we have those frameworks, this is almost impossible to change for us JavaScript or Python developers, because there is no convenient API to change that in the HTTP client. There are TLS libraries for JavaScript and for Python, but you would have to make the whole stack yourself, and you don't want to do that. And as I said, this is not the this list is not exhaustive. There are plenty of other things. There is, of course, like IP blocking. You can overcome that with proxies. There are some like personal access tokens Apple is trying to roll out. You can get fingerprinted based on the TCP messages. There is a lot of stuff. But these are the ones, if you look into like Cloudflare documentation for their bot management software, these are the things they're mentioning the most. Like these are the things they try to look into and that you can configure as the owner of the server. So how do we modify that? You probably have heard of the project Curl Impersonate. Again, a little show of hands. Yeah, great. It's a set of patches for curl. It's a community project that you've all seen it. So it's just a bunch of diffs that change the curl code to change all these markers we talked about on the previous slide. It also includes some fingerprint profiles to invoke, start the curl with some specific headers and things. These are all like predefined, and it's very, very easy to use. And it also uses the TLS libraries that the regular browsers use to match the TLS behavior, so you don't get fingerprinted based on your TLS, the client hello message. Now, some problems we got when trying to implement this for the JavaScript and the Python projects we worked on is that, well, it's not really maintained anymore, and even though there are some forks of this library that are maintained, they haven't been maintained for long enough, so we don't know if the maintainer is just going to disappear tomorrow. And yeah, there is not really like a strong community behind this. It's like a single developer who tries to make this work, and when they disappear and decide it's not worth their time anymore, we're cooked. Another problem is that there are pre-built binaries only for Linux and Mac OS on the old CPU architecture. It might not be a problem for you guys, but us as JavaScript developers, we don't want to compile stuff ourselves. So, well, and Windows people and people on the newer Macs, they couldn't use this. And there are also no pre-built JavaScript or Python bindings. There is no way of using the project from our JavaScript or Python code like directly. And even though there is this Node-lib curl, the bindings for curl, for Node.js, so for a bit we were thinking that we can just take this Node-lib curl and just remove regular curl and put this patched version there and then build it and have our JavaScript bindings. We tried that and we got something like this, which again, for you guys, it might make a lot of sense. For us, we were like, okay, version glibc 233 not found. Let me install the new glibc version, whatever. That wasn't it. No, it didn't go well. We spent not a lot of time on it, but it was very frustrating, especially as somebody not coming from the C background. This was, yeah. So imagine my surprise when some weeks later my colleagues working on the actors actually, so sorry, I didn't say I'm working mostly on the tooling, on Crawley, on all these tools. we have developers working on the actors themselves, so they are on that rollup. And I was quite surprised when they told me curl impersonate. Yeah, of course we use that in our in our JavaScript actors. Easy. I was like, okay, maybe you guys are like great, like cool. So this is what they came up with. They basically took the pre-built binary and wrapped it in JavaScript, just spawning the process. From your laughter, I can like.
It's a good code line.
That's one way to do it.
It is, you know. And you probably like, you know, when I first saw this, I was like so angry, like God, I was trying to make this work the right way, and you just did this. This is wrong. But they did it, yeah. And you probably all see the problem that, like, you know, if you run this multiple times, you will have, you know, you don't have the curl daemon yet, so. You'll create a bunch of connections, and you'll have to copy the input and output like through the standard output, and you know, stuff can happen. But they made it, and for their internal use case, it worked just fine. They managed to, I think this was for scraping TikTok or Instagram, which does have these TLS fingerprinting things, and but it worked for them, right? The issue is that when you publish this as an NPM package, there are two issues. One of them is that there were no pre-built binaries of curl impersonate for Windows or macOS on ARM, so you don't get Windows or Mac OS on ARM support for this package either. The other problem is that the NPM package is 20 megabytes because they basically took all the pre-built binaries, put it in the package, and ship it off to NPM.
Okay.
But as I said, maybe this is enough for their usage, right? Maybe their use case, you know, they unblocked their use case, they managed to ship it out, and as I said, actors are actors are Docker images, right? So you don't have to care about the no Windows support or the fact that the package is 20 megabytes because you just package it with everything else that's in the system in the Docker container, and it just works. And the fact that they are using it in their own TikTok scrapers and Instagram scrapers means that they're only ever gonna like send requests to like API endpoints, like just 3 or 4 API endpoints they need to unblock. So for them, this might work just fine. And oh, that's what the arrow is for. It's just pointing there. It's very simple to maintain. It's easy to understand, right? There's nothing to break here, at least from in the JavaScript code. But well, our team is developing this open source tooling, right? And we didn't want to be ashamed that, oh, the actor devs just got us, they were faster. So we were still thinking how to spoof the HTTP or TLS fingerprints from the Python scripts in a better way, in a way that we can ship to our open source users, you know, that other people can use it in their projects. Because as I said, the TLS internals are hardwired in Node.js and Python. It would take a lot of code to figure that out. And then we realized that Node.js and both Node.js and Python allow users to create like native add-ons, which is basically C code or some low-level code with interface that allows you to call it from JavaScript or Python. Probably if you know Python, this is a more familiar thing for you guys with like NumPy or Pandas. You know, these libraries for processing a lot of data, they are written in C. With Node.js, because it's used more for like web development, this is not really a huge thing, but people are starting to use this for like build systems for the websites because it's much faster. And so what we decided to do is we went with a bunch of Rust libraries. There was this very popular library called Request, which is for HTTP requests, and Rust TLS and H2. I think some of you mentioned these yesterday, so you probably know what these are all for. So we took these libraries, like Request, which already allows you to modify more stuff in that HTTP and TLS stack, like the HTTP to window size, stuff like that, which you don't get in the Node.js libraries. And we also forked Rust TLS and H2 and patched them slightly to match the fingerprints of those actual browsers, or to match the order of the headers in HTTP2. And with this, Cargo's patch feature was a huge help for us. Don't know if any of you have any experience with Rust. It's basically you put so you have package manager, right? And you can install packages from crates, which is their repository of packages. And if you don't want to use those, but you want to patch them, instead of the link to that repository, you can put a link to your GitHub repository. So the project then builds with your fork of that library from GitHub. So that was a huge help to us, because it's nice, it's very easy to set up, and it basically does what we needed to do, just tweak something very slight in the library and build the binary with that. This all gave us much better control over the HTTP and TLS internals, just because of the reasons I mentioned. And also with Rust, we found out that we didn't get any glibc issues, problems, just like with that libcurl, Node libcurl library, because there were a bunch of tools that we just said, okay, I want to build this for that, and it just happened. And there are also some GitHub actions that helped us tremendously. Again, repeating, not having much experience with low-level programming, this was a huge help. So all we had to do is to tweak these libraries slightly and to write language-specific bindings and interfaces. So for Node.js, we decided to emulate the fetch interface, which in JavaScript is the regular way of making requests in browsers. In Node.js, since the version 18, it's there too. And for Python, we emulated the HTTPX interface, and we are also building a separate CLI tool. We decided to mock the curl interface, because people know these interfaces, right? If they use JavaScript, if they use Python, they know the way to make requests. They don't want to learn a different library, or what's that called, what's this called. They just want to sort of plug and play that new library and make it work. So this package is already on both of the package managers. On npm you install it by npm init. From pip you install with pip install input. And so how do you use it? As I mentioned, we were trying to mock the interfaces that people are familiar with in either of those languages. So with JavaScript, it's in the top left corner, sorry. If you weren't using input, you would just remove the 3 first lines and remove input from there, just have fetch and that URL, and you would get the response. And now imagine you're getting blocked, like we got from Alza at the beginning of the presentation. So you just install the package, create a new input client instance, and just tweak it a bit like that. Of course, our fetch also accepts the other options you can pass as a second argument. And this way, your Node.js process or your program will send the request just as if Chrome sent it, exactly by tweaking all those HTTP headers, all the TLS things. The same with Python. Here, the change is even more slighter, because if you wanted to use HTTPX, you would just go with from HTTPX import client, and the rest would be the same. Well, it wouldn't accept the browser Firefox parameter, but the rest would be the same. And with curl, so we don't support all the options that curl has, all the 300 or how many. But some subset that's important for us as JavaScript, as web scraping developers, so like proxies and headers. I remember there was one more slide. Right. So I ran this curl clone with the same example we did in the beginning. I just passed an option called impersonate, told it to impersonate Firefox, and as you can see, the title is no longer wait a minute or just a moment. It actually got us the actual content of the page. So I believe that's it. Thank you for your attention. If you have any questions, this is the right time.
I have a question.
Yes.
So you're in that last slide you showed impersonate Firefox. Do you? I mean, I guess you haven't done this very long yet, but they do update them, right? So they want a fairly recent Firefox too. You can't just do in Firefox 5 years ago. That would have been rejected.
Yeah.
Do you anticipate to keep Firefox alive, or will you introduce Firefox versions? Or
No. That's absolutely one thing that's like on the very top of our like to-do list. We have. So before we had this package that generated different like header sets for different browser versions that worked only in JavaScript. We used that for other tools that did similar things, but only in JavaScript. Yes, so right now the fingerprints here, Firefox and Chrome, they are like hard-coded. We just have a set of these headers, the TLS ciphers. That's like, as I said, top of our to-do list. We need to make that either randomized or allow people to set versions of the browsers. Yeah.
I noticed you're using Rustls as the TLS library, and are you using that for both Chrome and Firefox?
Yes. So that's those are the little tweaks we had to do, because Rustls, I don't know, it doesn't support like ALPs, like the application layer protocol settings. A little thing that Chrome only supports, and it doesn't matter until you try to access Google servers or servers that use boring SSL that actually understands that, which could cause some issues. So yes, we had to tweak Rustls slightly, but as far as we know right now, it does work. The patches, again, I know I'm using it as sort of a shield, just a JavaScript developer. Maybe we broke something on the way, but right now, even with Rustls, we can basically get the same TLS fingerprint as the actual browsers have. Some of the things are sort of like mocked, so if the server really tried to poke into it, they would probably figure out that there was something fishy going on. But so far, it worked for our use cases. So
I'm a bit surprised that we've got this far, actually, because I know when Chrome dropped NSS support, a year ago or something, the Chrome impersonate guys were upset because we need that to emulate Firefox, but yet you were able to do it without even using.
Yeah, but
NSS. Yeah. And I think part of the reason you said that they haven't updated kernel impersonate for a year. I think that is part of the reason, because we dropped NSS support, and that is a massive blow to them for their Firefox simulation.
Could be, yeah.
Yeah, I think so.
Yeah. But as I said, we do quite a few like monkey patches to the TLS library. So yeah, if the server really decides to poke holes in that, it would probably
pretend to support a feature that, assuming they only use it for fingerprinting and not to actually use the feature.
Yeah, exactly.
Yeah, but I think that the major thing here to do is make the JA3 checksum to match, right? And then you just need that right order and all the extensions and everything in the same set as the other libraries. So only, within quotes, right? It's not. But as long as you do that, you come a long way, I imagine.
Do you know if these different fingerprintings, like on header and TLS, do the sites correlate them, or are those independent checks?
I think so, because the JA4 fingerprint is, I don't know, I can pull it up. It's basically JA4 fingerprint. It's combined from the TLS like information about the cipher suits and stuff. I think it's technical details here, and here we go. So the first part.
Protocol TCP quick, TLS versions, ISNI.
Yes. Oh,
those
wait.
are all just TLS.
No, yeah, I'm wrong. Okay.
That's all TLS.
Yeah, but then there's this HTTP client fingerprinting, which, this is just for
headers in this order they appear.
Yes,
So
in the order with the cookies with.
okay, so they end up in the same single view, right? So you need to have it, the order the headers needs to be the correct.
Yes, I think they're correlated. At least this standard or this.
In this checksum.
Yeah.
And even if they don't have to match today, they will have to match next week.
You're
right.
right. So and why not just make them? I mean, follow if you want to personate Chrome, use Chrome's header order and Chrome's TLS header hashes.
Of course, the main question is, since you re-implemented curl and Rust, did it take longer than
We, I don't know, we implemented like 5 options that are the most important for us. So I wouldn't call it curl at all, but yeah, actually all these like the CLI tool and the language bindings, they were fairly easy to make because we just used the libraries, okay, patch them slightly, but then we just made the interface for it and it's just like describing what parameters it takes and what output it gives.
Yeah, those --help shows alternative options, no one will probably ever notice.
So yeah, well for the CLI tool we used some library again. We just like glued a bunch of stuff together. That's why I was a bit reluctant to come here with this talk, you know, because our like colleagues were like, yeah, we signed you up for curl impersonate, like curl up. You're making the HTTP client, right? They'll love it. And I was like, guys, that's you know. But yeah, here we are.
No, I think it's super interesting.
Thank you.
And by the way, so impit is basically a Rust library, and you have bindings for JavaScript and
Yes.
and then it's wrapped in a CLI, which is also Rust.
Yes.
Or, yeah.
Yeah. So we have impit, which just takes the request and translates and like makes it work, and then we have bindings. But you can't really use, or it's harder to use impit from Rust directly because you need some special flags and install some special features. Those packages. But for Node.js and Python, you just download that from the package manager, and there are the pre-built binaries for each operating system.
But you basically have a C interface, right? Because it's because you use it from JavaScript and from Python, which basically
Only CFFI,
So I could.
That's probably how they do it, right? They do this Rust FFI thing. So that's how they export it to Python.
So that's maybe why it's hard to use from Rust, but maybe from C it would be okay. It's just I'm not trying to poke any holes, it's just,
no worries.
I'm interested.
So one reason why, you can use it from Rust. The one reason why it's hard is because of these patch dependencies. So if you install it in your project, you would have to set all these patch dependencies, even in your project, like override them, because otherwise
it's a little bit complicated to set up the build.
Yes, that's
Okay, sure. Cool. Thank you.
But the initially you were also talking about the canvas tests.
Yes.
That you cannot cover with that method.
No.
You still need the headless browsers. Or
exactly. Yes. This is just for the HTTP. The basically first request you send.
Do you have any plans on trying to do something like
the canvas?
The canvas thing or JavaScript related stuff?
Yeah. So we already have a package. We've been maintaining it for like 5 years. It's something I was talking about before. We generate random header sets, and we actually generate random sets, consistent random sets of these JavaScript values you can read from the interface, like the screen size and stuff. So we have like a package that randomly generates those, and then we have a package that injects those into your browser, like into that JavaScript environment. Basically overwrites all those properties with JavaScript proxies.
Okay.
And so when the website tries to read it, it actually sees those values you injected there. The issue is that it works well if they're just trying to read some values like the screen width, screen height, like just numbers, right? So it's easy. But once they try to write something in a canvas and they read it pixel by pixel, that's tough.
Yeah, then you really need a full-fledged.
Absolutely.
Yeah.
You would have to basically have a software renderer that replicates the behavior of like Skia and whatever.
Yep.
Yeah, you need a big chunk of the browser.
Yes.
Yeah.
But there are actual projects that do this. There's Camufox, which is they basically curl impersonate, but for Firefox. They take Firefox and they override some stuff. They inject some noise into the canvas rendering.
Uh-huh.
So yeah, when they read it back, they get like stuff that shouldn't be there. And,
Yeah.
it gets confused.
I imagine there's also some overlap with the various browser app testing frameworks.
That's the thing. We for web scraping we use Playwright and Puppeteer and Selenium,
Mhm.
which are exactly these like tools for controlling browsers automatically. So yes, if you want to control even that, so if you want to control a browser, you would use Playwright Puppeteer, but still it can tell if your browser is like this stock Chromium that ships with Playwright or Puppeteer. So you want to use an actual browser binary or that batched binary. And the other thing with browsers is that it's resource intensive. So if you want to scrape a lot of data, you don't want to have a browser running. And so you would want to do something like this. Have an HTTP client, possibly
Yeah,
lightweight.
basically pause the first test so they don't run the expensive test.
Absolutely.
So all the people who open issues at curl with this site is not working with curl, because exactly that we can refer to.
Yeah, we
Right.
raise issues in there. And,
Yeah.
yeah.
I mean, we get. I think it's like once every month or every 2 months there's someone
Yeah.
who gets like the server just shuts down the
Oh, yeah.
connection, resets the stream or whatever, and they say like, oh, this is weird in curl, and we say then probably it's the site which does it.
Actually, how do you? Sorry, that's a question from me to you. How do you tell whether that's like a problem with curl or a problem with the server?
It's really hard to tell, and that's why users report them, right?
Yeah.
Because
But
we just get a random reset. Why do we do that? It's not obviously we're stupid.
But often,
Right, go ahead.
often it's a public URL, so you can check.
I see.
I mean, you just go there with the browser, you go there with curl, and then it's pretty obvious that
Oh,
the client
okay.
is inspected. And
Right.
then you
Right.
fake some curl headers to see if it's a very simple block,
Mhm.
which is often the case. Just the user agent is checked
Okay.
for several sites.
Yeah, and then you know. But
Right.
otherwise, you have to sort of make an educated guess.
Yeah.
So we don't think this is a bug, but still they shut it down. They decide to do that for some reason.
Sometimes it takes Wireshark logs to really implement
Right.
it.
Mhm.
Yeah, and experience. Sort of, you get to learn how it looks like.
But it's a cat and mouse game, right?
Absolutely.
It will continue forever and forever.
Yeah,
Yeah.
So one reason why we tried to, why we decided to make this Rust package or to fiddle with curl impersonate, we had some packages before that did this only in JavaScript, something called scraping, which was again a patch of an actual library from JavaScript, but this stopped working because of these new ways of fingerprinting, the TLS fingerprints with HTTP2 fingerprints. The servers are getting smarter and
Yeah.
we
Oh, that's good.
Yeah, because they are running out of CPU cycles for those spaces.
Well, Instagram has still lots of CPU cycles left, but yeah, it's against their business model, of course. They want to. And Cloudflare is saying is selling this as a protection. So
Yeah, and I think the next level cat and mouse game is even more JavaScript stuff. That's going to make this even harder because then sort of proof of work things, do things in JavaScript. That's really hard to mock around with.
I think
Yeah.
Google started doing that recently. With like Google search, you can't just scrape the Google search results anymore because they do some
Right.
JavaScript challenges.
Yeah, and I know several open source projects have started this just to
Mhm.
combat this LLM sort of
Mhm.
torture, so that
Mhm.
do random things, which is super annoying
Yeah.
in many ways.
the other countermeasure are these infinite labyrinths they now
Yeah.
want to set up, right? Cloudflare has that as a service, and I think Fastly added
Yeah,
that
they
also.
have started to offer that too.
Yeah.
Probably, yeah. Yeah. We.
So when they say like, oh, this user agent doesn't look so like a real browser, they
Yeah.
That's actually more trickier because when they shut it down, it's more obvious. They detected us and
Yeah,
shut down.
yeah.
But redirecting or serving something else, that's more subtle.
Absolutely.
And sending you zip bombs.
Yeah. In effect, yes.
Yeah.
So we haven't encountered these yet. We have an actual tool, an actor that people can use to crawl like whole websites. But we haven't like noticed any of these labyrinths yet. But yeah, we have heard the news, and it's
It will
frightening.
come sooner or later, right?
Yeah.
Probably.
Yeah.
It's just a matter of time.
By the way, I think it's a pretty good idea that the CLI isn't it's not curl, but it mimics some of the parts of curl, especially since curl has like a larger like wider use cases.
Mm-hmm.
While this is pretty narrow, right?
Yeah.
Like curl has like and I don't like many different protocols apart
Yeah.
from HTTP, right?
Yeah, absolutely.
And,
Yeah, this is just.
and this is just HTTP because it's like a narrow use case,
Mhm.
but at the same time it will be familiar to anyone who has worked with curl. So I think this is
Yeah.
actually quite a good approach to do this.
Yeah, that was our goal. Yeah. I don't think.
Could add the impersonate option to curl, but for now only support curl.
Yeah,
For
and you know,
to do drop in.
we actually repeatedly get this question, right? Why don't we support the curl impersonate things natively? And yeah, just for the record, and so yeah, because no one has made it do that, right? And I have actually had sort of business potentials to work on stuff like this. But again, exactly like you mentioned, these patches to the TLS library, none of the TLS libraries actually makes this easy to do, which is kind of weird, strange. Why? So you have to patch the TLS libraries. I mean, the curl impersonate, they have TLS patches to do this. So, and most of the TLS patches, much more than curl patches. So, and for curl, it's mostly a matter of controlling the TLS library and maybe then reorder the HTTP headers. But reorder the HTTP headers, that would be, I mean, sure. That's sort of, we have that, I think I mentioned that in the to-do list for 20 years or something. But it's just, sure we can do that. No one has ever really cared about it enough to actually do it. It would be easy to do.
Maybe some company could do it for you.
Well, if someone really wanted to, we could do it. Someone could do it. Someone could pay someone else to do it. It would be easy. But I still think that the primary reason we don't have the impersonate things is that the TLS libraries don't make this easy, or they don't even provide this functionality. So we can't just do it. I mean, we would. So curl cannot just not offer this easily. We would use these specific particular patch builds of these TLS libraries. Sure, we could potentially do that, but we have not so far.
And there's a potential callback that you could provide to the curl to sort headers.
Yeah, but right, but sorting headers, that's easy. That's an easy task, right? We could do that in many different ways. It could be, you know, just providing an option, set a value to each header, sorted by this order, or provide a header callback, blah blah blah. That's not the problem.
Mm-hmm.
The challenge is the TLS parts, because we can. They don't offer that functionality. None of the libraries do.
And at some point they could also do things like there's a trick you can do to detect whether it's curl type piped directly to bash by read timings.
Right, but then you're adding
You
that
could do
more.
similar
Then it
things
also goes
to-
into this TCP fingerprinting and everything. So you can always fingerprint something else and something more. But I think, I mean, like this current impersonate, that's basically the TLS fingerprinting.
Yeah.
And I think the JA3 version, where they didn't involve the HTTP headers. But anyway, so.
Great, folks. Thank you very
Well,
much.
thank you.
Thank you.